Today we're going to talk about half-life, which you may have actually studied in some of your other classes. I think in earth science and in math classes they teach it as well. But half-life is the time that it takes for half of the atoms in a sample to decay. So we've talked about the nuclear reactions happen to make atoms more stable. The nucleus has to become more stable. So half-life is the time that it takes for half of those atoms to become stable. We can use this to date really old things, so you may wonder how they know how old the fossils are. And the way they do it is they look at the amount of carbon-14 in a sample, and they work backwards, and they can use the half-life to figure out how old it is. So these are some examples of some half-lives. You don't have to memorize these or anything. It's just to show you that the different amounts of length of time of the half-life shows you how stable something is. So potassium-40 has a half-life of only 1.25 years, which is pretty short. That means that it's really unstable because it's decaying at a very fast rate. Versus rubidium-87 has a half-life of 48 billion years. So it's really long, which means it's pretty stable. So when you're solving these half-life problems, there's 4 pieces of information you might be given. There's the starting amount, the ending amount, the half-life, and the total time that it took. So for the first question, it says the half-life is 5,739 years, and you start with a sample of 16 grams. So notice that question A is asking how much will you have left after one half-life, because that's how long one half-life is. And so all you have to do is take the original amount and cut it in half. So 16 divided by 2 would give you 8 grams. This amount of time, 11,478, this is 2 half-lives, because if you just divide it by the length of the time of the half-life, you get 2. So if you have 2 half-lives, you're going to cut it in half twice. So if you start with 16, cut it in half and you get 8, that was 1 half-life. Then take the 8 and cut it in half to get 4, and that would be the second half-life. So for letter B, it would be 4 grams. Anytime you're asked about a fraction for these, you want to start with the number 1 because that's kind of like 100% in terms of a fraction. So if you start with 1, after one half-life you would have half. After a second half-life you would have a fourth, so just keep on taking a half of whatever you have. After a third half-life you would have an eighth, and after a fourth half-life you would have 1/16. And it kind of helps to draw these out. What I usually do is write the number and then draw an arrow to represent the half-life. So you'd have 1, then draw an arrow to the right, and then a half. And then draw an arrow to the right, and then a fourth. For letter D, you just keep doing it 7 times. So if you start with 1, keep drawing your arrows and cutting it in half each time, and you should end up with 1 over 128 for letter D. For these questions, sometimes it's easier to list out your variables. So like for number 2, it says you're starting with 80 grams, so that's your start amount. You're ending with 10 grams, so that's your end amount. The half-life is 8 years. And what you're looking for is the total time. So anytime you have the start amount and the end amount, you want to start with the 80 and then just keep drawing arrows until you get to the end amount. So 80, draw an arrow, divided by 2 would give you 40. Draw an arrow to 20. Draw an arrow to 10. So you should have 3 arrows drawn. It took 3 half-lives to get from 80 to 10. So if each half-life is 8 years, and you have 3 of them, it took a total of 24 years. And for these problems, if you want to come in and see me at lunch, I can show you on paper. It's easier if I can write it out. Number 3, you've got your starting amount is 70 grams. Your ending amount is 8.75 grams. So just keep dividing it by 2 each time. So 70 divided by 2 is 35. That was 1 half-life. Divided by 2 is 17.5. That's 2 half-lives. Divided by 2 is 8.75. So it took 3 half-lives to get from 70 to 8.75. This time they didn't give us the half-life, they gave us the total time. So if we have 30 total years, and we went through 3 half-lives, each half-life is 10 years. And the last one's a little different because they're giving us the ending amount. So it says we have 60 grams now. How much did we start with originally? So this time you're just going to work backwards. Anytime you're given the total time and the half-life, if you divide the half-life into the total time, it'll tell you how many half-lives to do. So 10 divided by 1.25 shows us that there's 8 half-lives, but this time we're working backwards, so you're going to double the amount each time. So you're going to do 60 times 2 is 120. That was 1 half-life. Times 2 is 240. That was 2 half-lives. Keep multiplying it by 2 8 different times. And you should end up with a really big number. It's 15,360. And just a few uses for nuclear radiation. We've talked about you can date fossils. They're used in smoke detectors. We've talked about that before. Americium gives off alpha particles, which are not that dangerous because they're so big. But it makes a current, and smoke is big enough to block that current. So once the smoke blocks it, then the alarm goes off. Detection of diseases, so we can use radioactive tracers. And you've probably heard of radiation therapy for cancer. So we can shoot the cancer cells with radiation to hopefully get rid of them. These are just a list of things that cause a little bit more radiation than normal. So traveling in an airplane when you're closer to the sun, since the sun emits radiation, you get a little bit more. Going through luggage inspection or like a security inspection at the airport, they use radiation for that. Bananas have slightly more radiation. They're still healthy, so I'm not telling you not to eat them. They're still definitely much more beneficial to eat them than to not. So keep eating your bananas, but just know that they have a little bit more radiation. Smoking causes radiation. Anything electronic. Smoke detectors, we said, has radiation, x-rays. That's why they put that big heavy apron on you. Living within 50 miles of a power plant, which we actually do. We live within 50 miles of Sharon Harris. Using a cell phone emits radiation, so all these things do. But the good news is we've adapted so that a little bit of radiation doesn't hurt us. So don't have any nightmares or anything. None of this is going to kill you. And the last thing are just some scientists that you need to be familiar with. Marie and Pierre Curie are famous for studying uranium. And they discovered all kinds of information about radioactive elements and radioactive isotopes, but the problem is they were exposed to a lot of radiation because of it, and Marie actually ended up dying from radiation poisoning. And that is it for this chapter. So nuclear chemistry is pretty short. Make sure you know the vocabulary words, make sure you can write nuclear reactions, and make sure that you can do half-life problems. And there's 2 worksheets that I gave you, worksheets 3 and 4, that have some half-life examples if you want to try some of those. And that is it for this chapter.